Imagine a world without antibiotics. A world where even the smallest cut or scrape could lead to a deadly infection. It's a world where a simple scratch could kill. Infections that we now consider minor were once life-threatening. Where childbirth was a life or death gamble. Mothers and infants faced enormous risks during delivery, with infections often proving fatal. This was our reality before penicillin. Hospitals were filled with patients suffering from infections that modern medicine can easily treat today. Penicillin, a seemingly simple mold, revolutionized medicine. Discovered by Alexander Fleming in 1928, this mold had the power to kill bacteria. It ushered in the era of antibiotics. It saved countless lives. The production and distribution of penicillin during World War II marked a significant medical breakthrough. Before penicillin, bacterial infections were a death sentence for many. Simple infections could spiral out of control, leading to severe illness or death. Infections like pneumonia, sepsis, and even minor wounds could prove fatal. The lack of effective treatments meant that many lives were lost to these conditions. The discovery of penicillin changed all that. It provided a powerful tool to combat bacterial infections, transforming medical practice. It marked a turning point in human history. The advent of penicillin not only saved lives, but also paved the way for the development of other antibiotics, revolutionizing healthcare and extending life expectancy. The story of penicillin doesn't begin with its discovery. It starts with the observation that some substances inhibit bacterial growth. Ancient civilizations used moldy bread on wounds. This wasn't just folklore. It was an early form of antibiotic treatment. Louis Pasteur, the father of microbiology, observed something interesting. He saw that certain airborne microorganisms could kill anthrax bacteria. This observation hinted at the possibility of biological warfare against bacteria. The year is 1928. Alexander Fleming, a Scottish scientist, returns from vacation. He finds his lab in disarray. Petri dishes containing bacteria cultures are scattered about. One dish, however, catches his eye. A mold had contaminated the dish. But this was no ordinary mold. It had created a clear zone around it, inhibiting the growth of bacteria. Fleming realized he had stumbled upon something significant. Fleming identified the mold as Penicillium notatum. He named the antibacterial substance it produced penicillin. He published his findings, but the scientific community initially showed little interest. Penicillin was difficult to isolate and produce in large quantities. Fleming continued his research. He explored penicillin's potential as a therapeutic agent. He even used it to treat a colleague's eye infection with promising results. However, he lacked the resources to fully develop penicillin. Section 5. The Race Against Time. Scaling up production for World War II. As the world plunged into the chaos of the Second World War, the need for rapid and efficient production became paramount. Factories that once produced consumer goods were swiftly converted to churn out war materials. Fast forward to the 1940s. The clock was ticking, and every second counted. Nations were in a race against time, striving to outproduce their enemies and gain the upper hand. World War II was raging. The battlefields were scenes of intense combat, with soldiers facing not only the enemy, but also the harsh conditions of war. Infections were a major threat to soldiers on the battlefield. Wounds, no matter how small, could become life-threatening if not treated properly. Field hospitals were overwhelmed with injured soldiers, and the medical staff struggled to keep up. The need for an effective antibacterial agent was dire. Traditional treatments were often ineffective, and the mortality rate from infections was alarmingly high. Scientists around the world were in a desperate search for a solution. Scientists Howard Florey and Ernst Chain at Oxford University picked up where Fleming left off. They were determined to turn Alexander Fleming's discovery of penicillin into a viable treatment. They faced an immense challenge, producing enough penicillin to treat the wounded. The process was complex and time-consuming, and the initial yields were disappointingly low. They developed innovative techniques for mass production. Through relentless experimentation and collaboration, they managed to increase the yield of penicillin significantly. This breakthrough was a game changer. The United States, recognizing the drug's potential, joined the effort. American scientists and pharmaceutical companies pooled their resources and expertise, leading to an unprecedented scale-up in production. This collaboration not only saved countless lives, but also marked a significant milestone in medical history. Section 6. Penicillin's legacy. A new era in medicine. The impact of penicillin during World War II was profound. Before its discovery, bacterial infections were often fatal, especially in the unsanitary conditions of war. Soldiers who would have succumbed to infections from wounds or surgeries were given a new lease on life. It saved countless lives on the battlefield. The ability to treat infections effectively meant that more soldiers could return home to their families, changing the course of many lives and even the war itself. It revolutionized the treatment of bacterial infections. Diseases that were once considered incurable, like pneumonia, syphilis, and gonorrhea, could now be treated successfully. This marked a significant turning point in medical history. What was once a death sentence became a treatable condition. Patients who were once given little hope of recovery could now look forward to a future free from the fear of bacterial infections. Penicillin's success ushered in a new era in medicine, the age of antibiotics. This breakthrough led to the mass production of penicillin and the development of other antibiotics, which have since saved millions of lives worldwide. It paved the way for the development of countless other life-saving drugs. Researchers were inspired to discover and develop new antibiotics, each targeting different types of bacteria and infections, broadening the scope of medical treatment. It transformed human health and increased life expectancy. The widespread use of antibiotics has led to a dramatic reduction in mortality rates from bacterial infections, contributing to the overall improvement of global health and well-being. The legacy of penicillin continues to impact our lives today, reminding us of the power of scientific discovery and innovation. Section 7. Beyond penicillin, the rise of antibiotic resistance. The widespread use of penicillin, however, came with a consequence: antibiotic resistance. Bacteria, being adaptable organisms, evolved mechanisms to resist penicillin's effects. This led to the emergence of drug-resistant strains of bacteria. The development of new antibiotics became an ongoing battle against evolving bacterial defenses. The misuse and overuse of antibiotics exacerbated the problem. It fueled the rise of superbugs, bacteria resistant to multiple antibiotics. Section 8. The future of antibiotics, challenges and hope. Today, antibiotic resistance is a major global health threat. The development of new antibiotics has slowed. We are in danger of returning to a pre-antibiotic era where simple infections could once again be deadly. Scientists are exploring new approaches to combat antibiotic resistance. This includes developing new drugs, phage therapy, and novel drug delivery systems. Public awareness and responsible antibiotic use are crucial in this fight. Section 9. Conclusion. A testament to human ingenuity. The story of penicillin is a testament to human ingenuity and collaboration. It's a reminder of the power of observation, curiosity, and perseverance. It also highlights the importance of responsible stewardship of scientific discoveries. As we face the challenge of antibiotic resistance, we must draw inspiration from the past. We must continue to innovate and collaborate to safeguard human health for generations to come.